Welcome back everyone. Today is the session 5 from the chapter of moving charges and magnetism, and the topic is motion in a magnetic field. So here I have taken one example in which uh, a charge, that is plus q, is moving in a uniform magnetic field of magnitude b. ठीक है. So यहाँ पर what I am considering is that the first assumption that the charged particle is moving with a particular velocity, with a particular velocity, say v. ठीक है. In the direction perpendicular to the magnetic field. Magnetic field B. Now here, as you can see here from this figure, that this magnetic field is directed into the plane of a paper, and this can be also explained with the help of this diagram. That is, let us say this is a charge q which is moving with a velocity, say v, in this direction, and since the charged particle, that is plus q, is moving with a velocity, say v, in a direction which is perpendicular to the direction of the magnetic field. So let us say I am just drawing this is the direction of the magnetic field, say b. Okay, and so what will happen? The magnetic force will be acting in the direction which is perpendicular to both these two vectors, that is the velocity vector v and the magnetic field. So इसका जो direction क्या होगा? Let us say if I am just taking this as the let us say this is the y-axis, okay, and let us say this is the x-axis, and this is the then z-axis. Now here, and this is the origin. Let us say. So if the particle is moving along this z-axis with a velocity v, and the direction of this magnetic field is say along the y direction, then the magnetic force will be acting in a direction which is perpendicular to both these two vectors. That is, the magnetic force, say this is, let us say, FB. So this magnetic force will be acting in a direction which is perpendicular to the velocity v of this charged particle and the magnetic field B. तो इसका डायरेक्शन जो है, दिस एफ बी विल बी एक्टिंग इन दिस डायरेक्शन. सो अगर हम इसको यहाँ पर इसको डिनोट में अगर करना चाहूँ, तो यहाँ पर क्या, लेट अस से दिस, सो व्हाट विल हैपन हियर, अगर ये इसकी वेलोसिटी ये है, नाउ बी इज एक्टिंग समवेयर, लेट अस से in this direction. Let us say this is the direction of the B, and this the magnetic field is directed inward, okay, into the plane. So जो in now this magnetic force क्या होगा? Magnetic force will be the direction of the magnetic force will be such that it will be perpendicular to both these two vectors. So इसका जो direction होगा, it will be like this. ठीक है, this is the magnetic force. Okay. Now this magnetic force will provide the necessary now this force is directed in this direction, and this is going to provide the necessary centripetal force for this charged particle to move in a circular path. So FB will provide the centripetal force which will drive the charged particle in a circular path. ठीक है, आप इस फिगर से देख सकते हैं कि if the charge is moving in this direction, means I have just tried to just copy this diagram on this in this region where this charged particle is moving in this magnetic field of magnitude B. So अगर ये आपका z axis हो गया, ये अगर आपका z axis हो जाता है मान लीजिए, and let us say this is the ये y axis हो गया, so ये जो है आपका what will happen, this magnetic force B which will be directed in this direction when it will be perpendicular to both these two vectors, that is the velocity vector V and this magnetic field B. ठीक है, तो इसका डायरेक्शन क्या हो जाएगा, it will be directed towards, let us say this is the center of this circular path, so it will be directed towards the center of this circular path and it will be providing the necessary centripetal force which will drive this charged particle in a circular path. So अब हम इसको now the centripetal force जो है will be provided by this magnetic force. Now the magnetic force FB is equal to given by Q VB sin theta. ठीक है, so this will be equal to Q VB हो जाएगा, where V is the velocity of this charged particle and B is the magnitude of the magnetic field and Q is the magnitude of the charge. ठीक है, ये हो गया, and this will be equal to the centripetal force which is given by mv square by r, where m जो है this is the mass of this charged particle, v क्या है, this is the velocity, this is the linear velocity of this charged particle and r will be the radius of this circular path. ठीक है, so अब हम क्या कर सकते हैं इसमें, so it implies that अब यहाँ अच्छा हाँ one more thing, the unit of this magnetic field B, unit of magnetic field B is Tesla, and Tesla जो है, this 1 Tesla is equal to Newton second divided by Coulomb meter. So 1 Tesla is equal to Newton second divided by Coulomb meter. ये एक Tesla, and not Tesla is a very big unit. So Tesla is a 1 Tesla is a very is a big unit. ठीक है, so therefore we normally use a smaller unit called Gauss. Now 1 Gauss जो है is equal to 10 to the power minus 4 Tesla. This way. Tesla is a very big unit and therefore we normally use a smaller unit, that is Gauss, and 1 Gauss is equal to 10 to the power minus 4 Tesla. Okay. So this is, I think I have not discussed about the unit of the Tesla in my previous session, so that's why I am just telling it here. So the unit of this magnetic field B, the magnetic field is Tesla, and 1 Tesla is equal to Newton second divided by coulometer. And since Tesla is a very big unit, so therefore we normally use Gauss, which is equal to 10 to the power minus 4 Tesla. Now, from this equation, what we get is that V square upon R is equal to V square upon R, mv square upon R is equal to QVB, or it implies that mv upon R is equal to QB, or it implies that V, that is the velocity of this charged particle, that is the linear velocity of this charged particle, V will be equal to so V will be equal to R Q B divided by M. Okay, so this is the linear velocity of this charged particle when it is placed in an this external magnetic field B, and when this external magnetic field B is perpendicular to the velocity of this charged particle. ठीक है, so इस केस में जो linear velocity मिलेगी, and this is the linear velocity of this charged particle when it is moving in this circular path of radius r. ये r क्या है? This is the radius of this circle. ये आपका जो radius हो जाएगा, this one. So this r is the radius of the circular path, and now there are other things we can from this formula we can also calculate the angular velocity. Now v is equal to r omega. So r omega is equal to r q b upon m. So from here it implies that the angular velocity omega will be equal to q b divided by m. Okay. Now we also know that omega is equal to 2 pi upon t, where t is the time period, that is the time taken to complete one revolution. So it implies that 2 pi upon t is equal to qb upon m, or it implies that t will be equal to, that is the time period will be equal to 2 pi m divided by qb. Okay, so this is one formula which we have derived with the help of this equation, and we have also got one important formula, that is the angular velocity will be equal to qb divided by m. The linear velocity will be equal to this, that is v is equal to r qb divided by m. And so these are the three important. Apart from this, now frequency भी एक है. Now we know that this frequency is equal to 1 by t. So it implies that the f will be equal to qb divided by 2 pi m. And what is frequency? Frequency is the number of revolutions taken in 1 second. Okay, the number of revolutions taken by this particle in 1 second is called the frequency. So frequency will be equal to qb divided by 2 pi m. So this is another important formula. Okay. So in this session I just wanted to discuss about this motion, that is the motion of a charged particle. Okay, when it is placed in an external magnetic field in such a way that the velocity of this charged particle is perpendicular to the direction of the magnetic field. So in this case, this charged particle will follow a circular path, and and with the help of their relation, that is this magnetic force that is magnetic force, that is QVB is equal to mv square by r. So we have used this relation, that is the magnetic force will provide the necessary centripetal force so that this charged particle revolves in a circular path of radius r. From here you can also calculate the radius of this circular path, that is अगर हम यहाँ से बात करें then r, that is the radius of the circular path, will be given by mv square divided by qvb, or it will be equal to mv divided by qb. So this is also one important relation which we have got by using this relation, that is the magnetic force will provide the necessary centripetal force, and if the magnetic force is equal to this providing the necessary centripetal force, then this charged particle will move in a circular path of radius r, and the radius will be given by m into v divided by qv. So these are some of the important relations which we have got by using this formula. That is, one is the radius of this circular path, second is this linear velocity, which is equal to r qb divided by m. Then we have also found the angular velocity, then we have also found the time period, and then we have also found one more relation, that is frequency. Frequency was equal to qb divided by 2 pi m. Okay, so these were some of the important relations which we were able to derive by using this formula. Okay, so this is all I have for this session 5, and in the next session we will be now taking a few numerical problems based on what we have studied till now, that is starting from session number 5 up to session number starting from session number 1 to session number 5. So in the next session we will be taking up a couple of questions, and thereafter I will be proceeding with some other topics also, and so till then, have a nice day. Bye.